Hello everybody, welcome. This is paper 1 from November 2023, time zone 1. Let's work through this and see what we can do. This question right here, geez, this is another challenging question. Let's work through it, The diagram shows a map containing a long winding road passing a lake. The shape of the road can be modeled by the function r of x is equal to x plus 2 cubed plus 3x squared minus 2x. All distances in the map are in kilometers. The local hospital is located at point H, which has coordinates -2, 6. That's right here. To save time during emergencies, the local community is planning the construction of a bridge over the lake. The bridge will be built such that it is normal to the road at point H and will connect to the hospital at G. So once again, this is a pretty heavy algebra test so far. Somewhat uncommon, but not too bad. It's good practice all the same. So we've got this road that can be modeled by this function right here, this winding road, and we have the hospital at point H, and we want to build a bridge. And the bridge is normal to the road at point H. And what that means is it's at a right angle to the function. So we know if we have some function, for example, and I'll write it in the corner here. If we have some function, and let's say a cubic function like this, we've got a tangent to the function, and then we've got something that is normal, that is to say at a right angle to this tangent line in this case. And that should help us out. So the first question is, using your graphic display calculator, find the value of r prime 2. So they're saying, hey, you don't need to take the derivative and do this yourself. We don't need to see the derivative. Just find r prime 2. That is to say, the value, evaluate the derivative at the point -2. So let's go ahead and look at the calculator. So we don't need to find r prime. We just need to find the derivative at the point -2. So a few different ways we can do this. I'll show you both. Easiest way is going to be algebra. Oops, sorry, not algebra, calculus rather. And we want to find the numerical derivative at a point. The variable is x, the value of 369. I've actually got to get a new document because it's a little cluttered. All right. Menu, calculus, numerical derivative at a point. We want to find the variable x, and we want to find it at -2, the first derivative. And now we have this notation which is saying the derivative of what at the point x is equal to -2. Let's put a function in. It's x plus 2 cubed, whoops, plus 3x squared minus 2x, and we want to find it at x is equal to -2. There it is. X is equal to -14. So r prime of -2 is equal to -14. I'll show you the other way because sometimes it's actually helpful to do it this way as well. If you go on your calculator and put in the function as well, x plus 2 cubed plus 3x squared minus 2x. Here's our function. I'm going to zoom out just a little. And we want to find the derivative dy dx at some point. And so let's actually first get that point. Graph trace. Let's actually create a point. And let's set the point at x is equal to -2. A little cluttered. Let's move this over here. So we've got the point x is equal to -2. And now let's find the derivative dy dx at this point. And there it is once again, -14. This is kind of nice because you can do these things as well. you go geometry and you want to, let's say, find the tangent line. It won't give you the normal line, but it'll give you, let's say, the tangent at this point, which is negative 14x minus 12. So it gives us not only the slope of the line at a point, which is what a derivative is, but it also gives you the y-intercept. Means we're going to cut the axis right here at negative 12. There it is once again. The derivative, that is to say the slope of this tangent line at the point negative 2 is equal to negative 14. Okay, good. Okay. Let's go on to part B. So going back to the document, it asks us to find the equation of the line normal to Rx at point H, which can be used to model the bridge. So we want to find this equation that is normal at a right angle to Rx. And remember, the IB rarely asks you something just as a piece of trivia. If they give you something, if they're saying find the derivative at this point, negative 2, the slope of a line of this function at a given point, chances are they're going to want you to make use of it. So find the equation of the normal to Rx at point H at negative 216. So let's go ahead and do that. I'm going to use this space over here. An equation of a tangent or a normal is going to have y is equal to mx plus b, or mx plus c. We need to find the slope. We know that the slope of the tangent is equal to negative 14. That means the slope of the perpendicular, if negative 14 is the same as negative 14 over 1, we can take the top and the bottom, or the numerator and denominator, switch it, and since it was previously a negative, we're going to multiply it by a negative, and this should be our new slope. So the slope of a line that is perpendicular, which is what the normal is going to be 1 over 14. Y is equal to 1 over 14 x plus b. We don't know what b is, but we do know a value of x and y that is on the line. So let's substitute x and y into this equation. Y is equal to 16, and x is equal to negative 2. And that should be enough for us to find b. So I'll just work that out. Negative 2, 14, 1 plus 16. Okay. As a decimal, b would be equal to 16.1428, so on, or 16.1. As a fraction, it's equal to 113 over 7. So let's write it out. Y is equal to 1 over 14x plus 113 over 7. And if you want to write the decimal equivalent for both, that's perfectly fine as well. Just 3 sig figs. Alright. Now they want us to determine the length of the new bridge. 3-mark question. It's actually kind of a nice question, to be honest. I do like this question. Determine the length of the bridge. So, we know how to find the distance. We even had a distance formula question above with those Voronoi. The distance is just going to be, we can imagine, Pythagorean theorem. It's going to be this distance right here. We know one coordinate point, but the question is, what is this coordinate point? What are the x, y values for g? And given that, and remember, the IB often presents a kind of sequence of questions. Given that we have an equation of a line, and given that we've got a function, we know that one intersection point is at h. If we were to extend this through, there'd be another, but we don't need to build a road here. But if we look for the other intersection point of this line, it should be g. So let's go back to the calculator screen, and let's look at the function. So here's the function itself. We already plotted this point right here. I'm going to get rid of it and imagine as if we just have the function itself, as if we just graphed it. Let's go ahead and add the other function. So graph entry, let's put another function in, and let's put the one that we have. I don't have it as a decimal, so I'm going to use this value of with fractional values. 113 over 7. Okay. there's our function, and it looks pretty good. It maps what we have over here. Let's go Menu, Analyze Graph. Let's find the intersection between 2 points. This one, if all things are good, should be at 216, and it is. That's very nice. Looks like we're in a good place. And here, this one shouldn't be dismayed that it's a not very nice decimal. So we've got a coordinate point, which is fantastic. So let's go back to the document, and let's put those values in. So we've got a point. We've got another point right here. And that point is, going to clear up some space, that point is negative 7.54 and 15.6. Okay, good. Now let's just find the distance. So let's write the distance formula out. Let's write it here. Distance is equal to the square root, this is given to you in your formula booklet, x2 minus x1 squared plus y2 minus y1 squared. Distance is, and then this is us just drawing out the Pythagorean theorem. This is going to be negative 0.7.54 minus, watch your negatives here, squared, plus, and this is me running out of space, 15.6 up to 16 is actually just going to be 0.4. So this is going to be a distance of, please excuse the shorthand, there it is, 0.4 squared. How did that happen? If you need to see, y2 minus y1, 16 minus 15.6. There it is. Okay, here we go. Let's write it out. And negative 7.54 plus 2, square that value, plus 0.4 squared, take the square root of all that business, and it gives us 5.55. I think potentially it is easy to get mixed up with the negatives, so just again, I do like these kind of intuitive explanations. Negative 7.54 going to 2, that means if we start at negative 7.54 and go up to negative 2, we've traveled negative 5.54. Similarly, if we're at 15.6 and we travel up to 16, these being both y values, that means this value right here is only equal to 0.4. 0.4 squared, negative 5.54 squared, and then you can use your Pythagorean theorem. Add those together and take the square root. Okay, and so final distance in the end is 5.55 kilometers. Alright everybody, I hope that was helpful, and as always, best of luck. Take care.